Okay, so I don't have any video for my video capture. I'll just be capturing the screen since I'm just testing out my tablet to be the board for now. So I'll solve 5.24. Under constant pressure conditions, a sample of hydrogen gas, oh my, hydrogen gas initially at 88 and 9.6. So this is temperature and this one is volume. Is cooled until the final volume is 3.4. So you have a case of temperature 1, volume 1, and then you have a volume 2. So basically this would be under Charles law. So catality mo given is temperature and then you have two volumes. So for that I could employ Charles law for that. Your Charles law says that your volume is inversely proportional with your temperature, or you can say that V1 all over T1 is equal to V2 all over T2, and then you have a 88 9.6. For your first condition you have a V1 9.6 liters, and then your temperature is 88 degrees Celsius. 9.6 liters, 9.688. Okay, and then your volume 2, your second condition, is 3.4 liters, and then the question is the final temperature. 3.4 liters. So this is an easy peasy. I think I shouldn't be doing this, but anyway, I'm just practicing my gadget here, so you can just skip. That's the good thing with videos, you can just skip and find something interesting. Okay, so may I substitute? I'm looking for my V2, T2, sorry, this guy over here. So that should be a T2, which is equal to V2 multiplied by your T1. Of course, it's simple algebra, and then you have a V1. So may we substitute? You have a 3.4 liters, and then multiplied by your T1, which is 88. So basically for your gas loss, you should be using your absolute temperature. So for an SI unit, it should be in Kelvin. So you have to add a 273.15. So that would be Kelvin now. Then you divide it with V1, 9.6 liters. So you can cancel out the liters, thereby having a unit of Kelvin for your T2. Okay, so can I get my calculator? Of course, you have 3.4 liters multiplied by 88 plus 273.15 all over 9.6 liters. Chadang! And there you have it. You have 127 in 3 significant figures, or maybe in 2. That should give you 130 degrees Celsius. Okay? Sorry, in Kelvin. 130 Kelvin. So you may change it to degrees Celsius so that there would be no ambiguity. Maybe I have to specify, because this is the book. So there may be a lot of ambiguities, especially when you don't read your book. But anyway, it's not my problem if you will not read your book. My problem only is, your problem only is to pass the quizzes and exams. So it's up to you if you will read it or not. 130 minus 273. So I think the volume expands, so therefore it will cool. I think it is also stated in the problem that it will cool down. Constant pressure, see, that's Charles' law. Initially at 88 and then it is cooled. So therefore you can expect that the temperature would be a lower this time for the second case. So that is 130 minus 273, and that will give you a negative 143 degree Celsius. Okay, so that's 4 minutes. Maybe I'll have to, since I've already tested my gadget, maybe I'll be looking for a more harder problems. Thank you guys for listening.